The constant e. Let's focus in on a portion of our formula. Here's our formula, a equals p times 1 plus r over n raised to the nt power. Specifically looking at just 1 year, let t equal 1. So now it's just to the n power because t is 1. Now using the special case of r equals 1, so the rate equals 1, so now this is 1. Does this approach a number as n gets very large? Use your calculator to complete this table. If we plug in 1 for n, this would be 1 plus 1 over 1 raised to the first power. This is 1 plus 1, so it's 2 raised to the first power is 2. We're going to use our calculator on the next slide. Alright, so we can see that as n increases, we are approaching a number that's very close to 2.7182. Mathematicians proved that as n approaches infinity, 1 plus 1 over n raised to the n power approaches the number they were to name e. E is an irrational number. Its decimals go on forever and never end, repeat, or form a pattern. Its first few digits are 2.7182. Here are the first 1,000 digits of e, but e has been calculated to millions of digits. Your calculator actually has a key for e since it has many uses. E shows up in a wide range of problems in the areas of math, science, business, economics, medicine, etc. It was first used, but not identified specifically, by John Napier in about 1618. It was derived by Jacob Bernoulli and then used by Leibniz and Huygens in the late 1600s. The designation of the letter E for this number was made by Euler in the early 1700s. It was first computed from solving the problem we've been exploring, compound interest. Since then, it has been computed many different ways. The letter E allows us to simplify the continuous compounding of interest, where n goes to infinity, by replacing this formula with this formula. A equals p times 1 plus r over n to the nt power is now a equals p times e to the rt power, where a is the amount after t time periods, p is the principal, or the starting amount, r is the growth rate per time period, and t is the number of time periods. Let's check this by substituting into the formula for our example of $1,000 earning 10% interest compounded continuously. So A equals P times E to the RT. P is 1,000, our rate is 0.1 for 10%, and T is 1 because we want to see after 1 year. So that equals $1,105.17. That's our account balance after 1 year of being compounded continuously. We can now add a row for continuous compounding by using E in our calculators.